Hi there, and welcome to Tony's Science Tidbits. This short lesson focuses on matter and the particle theory. In Lesson 1, we're looking at mass and weight. But let's look at matter first. What is matter, anyway? Well, matter is anything that has mass and takes up space, and we call this volume. If we look at this lumberjack, we see all kinds of examples of matter. The lumberjack himself, the axe he's swinging, the tree, the grass, even the atmosphere around him. They all have mass and take up space. As a matter of fact, we are surrounded by matter. In this unit, we will focus on water itself. It certainly has mass. Have you tried to lift a bucket of it? Well, water certainly does have mass. There's no question about that. And space, well, it occupies 70% of our planet. Remember back in Science 8? That's a lot of space. And remember, we measure volume in liters and milliliters as a couple examples. We better review a few of these terms first before we go much further. We're talking about the word mass, and we often confuse things like mass and weight here on the planet Earth, and we use them interchangeably. But in fact, they are different. Mass is how much matter is in an object. See, we measure mass in grams, milligrams, kilograms, so on and so forth. However, we have to be diligent not to confuse it with weight. You see, weight is a measurement of the pull of gravity on a certain mass. For example, we may weigh 100 kilograms on Earth. However, if we were to go to the space station, we would feel weightless. But you're not massless. You are still made up of the same amount of matter. See, we often misuse the term weight when we state we are weighing ourselves on a scale. In reality, we are measuring our mass. Weight is typically measured in newtons. If you go to the learningodyssey.com, they have a weight to mass comparison on Earth and the Moon, where you can see how different masses vary. So on the display here, I've just shown an example where on the left they have a graph and they plot the mass of an object along the horizontal axis in kilograms and the weight of an object along the vertical axis in newtons. We have a scale on the right that measures weight and a mass, several masses actually, that we can hang off of this scale to get different weight measurements. The mass of each object is listed on the side of it. Right now we're looking at a 1 kilogram mass on Earth, and we can see that its weight is approximately 10 newtons. If we switch to the Moon, we see that the mass has stayed the same, 1 kilogram, but the weight has significantly decreased down to close to 1. This is due to the size of the Moon. The Moon, being much smaller, has less gravitational pull on the object. Thus, the object has less weight.